So, is everybody settled in? Cool. My name is Alexander. I'm not going to introduce myself properly right now. Before talking to you, I would just like to give you a little test. I'm going to ask you 6 questions, and I just want you to react. Don't think about the meaning of what I'm going to say, like the exact definitions. Just raise your hand, spontaneously. This is just so that we can get to know each other, right? Okay, so, the system we're working on now, does it have spaghetti dependencies? Don't think, just raise your hand. Cool, right, don't think. It's ruled by the database. All right. It's not ruled, pardon? It's not ruled by, oh, good enough. Okay, excellent. It's a ritual to deploy it. Oh, great, okay, so, cool. It doesn't have a business layer. Okay, close enough. It has fewer per unit tests. Oh, here we go, here we go. And end-to-end tests. Or should the question be, what are end-to-end tests? Maybe. Okay, so this is basically done to get your, blood pumping, raise your hands, get your cardio up. So, what I'm going to be talking about is a system like this. So this is my system. It has all these properties. All right. So, my name is Alexander. I'm from Sweden. Just to give you a feeling for who I am, this is what I do. So I'm mostly a Java guy. I cheat at testing. That said, I cheat at testing. I also have a Lean Pub project. It's very, very far from finished. I'm writing a book on developer testing. Right now it's full of crap, basically, but there's 3 chapters full of typos and stuff like that, but it's for free, so have a look at it now, and in 1 year it's going to be the greatest book ever. No, probably not, but I have a Lean Pub project. So, what I'm going to do for the next 10 minutes is to give you a description of my system, just to sort of tell you where we are, and I sort of hope that you will feel some resemblance. So bear with me for 10-15 minutes. I'm going to tell you what our system looks like, and I'm going to tell you how we fixed it. Because I'm going to talk about a real system. It's not going to be any general principles or anything. It's just a story of our system and what we did to fix it and what we are doing to fix it. So 15 minutes of problems and pain. So let's talk some architecture or dependencies. I started this talk by saying something. My system's dependencies are like spaghetti. So initially I animated this slide, but basically it got too complicated. But my system is, it's a simple system. It has a web front end, it has a back end. The purpose of this system is to write things to stuff in the network. So there are like routers, switches, and this system, people are sitting in front of the screen, entering IP addresses and stuff like that. So that's the purpose of the system. And it managed to get entangled into this mess. So basically think of the big squares or rectangles as like ear files or war files or something that packages something else. And so what we can see in this graph is maybe like this would be acceptable, probably it's not good, but it would be acceptable. But what's very typical for this system is that all of its dependencies are pointing to towards one thing here. And that thing happens to be a homemade, home packaged, I see, anticipation. No, it's not very dramatic. It's a homemade, home packaged installation of JBoss. So whenever you are taking this system elsewhere to another developer's machine or to a new environment, you have to have this 300 megabyte big file which has all these artifacts and special tweaks. You have to bring it with you, and when you set this up in an IDE, it takes a day. And if you have done this 3 or 4 times, it takes half a day. just to set it up in Eclipse or IntelliJ or whatever. So at least to me that's sort of a problem. So that is just packaging, and you see there is some enterprise message bus. There always has to be a message bus involved, and there is a developer pack from 2004, and these are things you need to install on your machines locally to get this started. I'm not going to go into details because I'm going to burst out in tears soon enough, so I'm just going to skip ahead. Now, this 300 megabyte web application server, to me, when I joined this project, the best metaphor for this would be the black hole. Because imagine yourself, you're new or something, you're new on the project, you want to sort of get started, you want to show everybody how cool you are, and then you just get these enormous files with all these tweaks in it. And what's funny, what may not have been very apparent from the last slide is, I'm just going to go back, is that this thing here, this is a jar file. Actually, this file is packaged and put in that server. So this guy, who depends on that, and the server, you don't really know what version you're working with. So this is like the parts of the application parts. It's a very, very complicated thing. Of course, there are data sources. You configure data sources in an application server, and it so happens that this configuration has been around for a good while, and it contains too many data sources. Some of them are used, some of them are not, and try figuring out which ones. It's the detective work. We'll see that much of this is about detective work. There are some configuration files. Like, again, the application, of course, has configuration files. It picks some configuration from a database, but it has configuration files. And again, you don't know how many they are, you don't know what's in them, you don't know what's used or anything. They are in this big package. And there's some other candy as well. In total, this amounts to this big jar file, which you copy around and you don't touch it, period. All right. Ooh. Who knows what this is? One. Yeah, Lord of the Rings. So, this poem says, one database to rule them all, one database to find them, one database to bring them all, and in the darkness bind them, I don't know? Yes, I got that right. And in darkness bind them. So, that's another typical characteristics of my system. It has one database, and the reason why I'm sort of emphasizing this is that I've seen this for so many cases. There are systems, they have one database, and then you don't touch that database. I mean, there are systems out there, if you, for example, if you take the architect role and say, okay, let's move that system, let's upgrade the hardware. Whoa, let's not. We can't move the database. So that's sort of the case for this system. This system's database has been around for 10 years. It's an Oracle database, it's very, very old. We're going to talk more about this, but okay, actually I'm being a bit unfair. There are two databases. There is the production database and there is the everything else database. The everything else database is shared by all developers. All developers are working with the everything else database, and the suite of the non-working suite of the non-working end-to-end tests is also working with the other database. So you sort of see what's coming, right? This non-working suite of non-working end-to-end tests. Okay, I am a bit unfair. Actually, there are three databases. The third database is, of course, completely out of sync with these two other databases. It's the system test database. It's completely out of sync. Now, deploying this baby, once we clocked deployment to 8 man-hours, well, that was sort of an incident, but deploying this follows the pattern of the manual deployment list. You know, you have a text file which is 5 years old, and if it's 5 years old, you're lucky. And it has these instructions. It starts with, as user Joe, log into system X using that password. Now, start WinSCP 1.32 and copy the files from your local machine to that other machine. Now, before doing that, make sure that you clean up that directory. Stop the application server with this handmade script that does these specific special things, and then clear the temp directory on your server. And so it goes on for like 15 to 20 stages, and this list is like this long, and the funny part is that it still requires so much tacit knowledge. I mean, if you gave this, the scary thing is that it looks like proper instructions. But if you gave this to somebody who's not been working with the system, they would not be able to follow it anyway. So this is sort of my illustration of this. This is the only slide on architecture I have. I'm so happy. I still need that recording. I'm so happy about the reaction. And actually, it's like this. I'm not a big fan of this. There are frameworks, and we're not going to single out Seam in particular. Grails, Rails, Play. Many frameworks encourage, or maybe not encourage, that's not fair to say, but can make you do this, basically. And I don't want to bash Seam, but I'm going to do it anyway. Seam is, for those of you who don't know it, Seam is a framework which is supposed to create a seam over enterprise Java. That seam is about making your persistence as easy as possible by putting it directly in the web layer. It's a brilliant idea, not. So what happens here is that everything, if you have some business rules or anything, they just go away. They're not supposed to be there because you can do persistence in your view. And this is, who can tell me when this is a good idea? Oh, no, sorry, I'm going to move. Who can tell me when this is a good idea? Because apparently there is an entire framework, there are people writing books about this, saying, I love Seam. So it has to be, there has to be a business case for it. When is this a good idea?
Prototype.
Pardon?
Prototype.
Prototyping, okay, cool. That is true. My answer to that was basically, it's a good idea if your display logic contains no more than one conditional statement. So if you have some kind of, let's say we're using the address book as an example, if there is one if in that addresses book view, should we happen to have a view on that, then you can work, and that's sort of prototyping. But as soon as you have two ifs, you're pretty much screwed, because that turns into a business rule. So
but Seam does not enforce you to do this way.
yes.
You have a business layer based on it and do the dependency injection based on it. I'm not a big fan of Seam, but you are truly over-criticizing it.
Okay. Well, I can tell you this, I'm going to skip ahead, and fortunately, there is a way out of this. Yes, you can use Seam for dependency injection. Yes, okay, I am over-criticizing it a little, but there are books on Seam which sort of the entire book is built around moving the persistence up in the view layer. So
I don't have practical experience of building such applications. So it's just when your objects are able to display themselves on the screen. It's different
Mm.
for everyone.
Exactly. So there is again there is a limited area of use for this, but as soon okay, let's switch context and say for our system, which happened to have plenty of business rules, this was a very bad idea. And yes, Scene doesn't force you, just to get this on tape, Scene doesn't force you to do this, but a lot of tutorials on Scene are showing you this. So in our system, what happened is that people adopted this. So this was the problem. And this makes every kind of unit testing very hard. Speaking of unit testing, I did tell you that we had 100 unit tests.
100,000.
100. 100. 100. And half of them, not 50,000, 50, were in fact what I call integration tests. Now there is a very clear definition of unit test, fortunately, and that definition says that basically you're not supposed to touch file systems, you're not supposed to touch like web sockets, and anything that's sort of outside of your code. And our unit tests touch this enterprise message bus. So naturally they failed, period. Our end-to-end tests were written in WebDriver. This is actually from another presentation, sorry I'm reusing a slide, but they were written in WebDriver. And if you use like a record playback paradigm, you just sort of use this little thingy where you can just say record my test, I'll be fine. This is basically what you get. This is really just recorded. What happened in our test is that people kept building on this. The problem is that it had lots of Ajax. And the way Ajax was coped with was through the various thread.sleep. Now I know that you know that this is not how you do Ajax in WebDriver, but this is what we had. So all in all, what happened here is when you join a project like this, at least you get overwhelmed. You don't know where to start.
Don't join. Update your CV.
Exactly. So there are various strategies to handle this. Updating your CV, throw everything out. But the reality for most of us is that this is what we face, and we have to learn to cope with this. So one takeaway is don't freeze when you see this. It's just about picking some kind of strategy. Where do we start? And that's exactly what we did. We sat down and picked a very simple strategy. How do we go from here? We have to fix this somehow, but fixing it's a huge task. So where do we start? So we agreed on some very simple things. I mean, the unit testing things, I am oversimplifying a bit, but it's just craftsmanship. Of course, if you have like not testable code, writing unit tests is very, very hard. But basically we said, we're just going to write unit tests. And if we have to do some kind of refactoring, we are going to do that refactoring. But that's just code. It's just about writing code. As for this business layer thing, the view thing and the persistence in the view layer, again we said we are going to have a business layer. We're going to introduce a business layer. And guess what? We even drew a picture of that. And it wasn't UML. It was basically like 3 squares, like web, business, and everything else layer. But we had a picture. We had a picture of that. And the thing is, this is not something you do overnight. You can't just conjure up a business layer in a spaghetti system. So we said, okay, this is a goal, we're working towards this. this is a working agreement. In half a year, we'll see what happens. What we did do is that we said, okay, so we're going to run automated end-to-end tests of happy paths. Now, running end-to-end tests through the web layer is usually a bad idea, or usually at least branded as a bad idea. So I will sort of explain to you the rationale behind this, because it's sort of important. Now, we decided on automated tests because there were not that many developers in this particular team. We were limited in resources, so we needed some kind of automation. We couldn't have people. We had like one tester who wasn't always available to us. So we really needed to do this automatically. And the other thing is, testing in a way that this application would require is very boring. I knew that there was a term called code monkey, but like a week ago I learned that there is a term called test monkey. And this is something we didn't want to become, and this is something we needed, that kind of testing, because everything was like a big spaghetti, and if you touched it here, it broke there. So you needed like this manual regression testing to ensure that you didn't break anything. But we sort of didn't want to do this because this would really send us off crying, so that's why we decided for automation. Now, as for Happy Path, Happy Path is like a single, like a couple. For an application of this size, it's like 30, 40, no more, paths through the application that, like the simplest possible path. In this case, it was like add a new thingy in the network, configure the thingy in the network, add a new virtual private network. And really the simplest one. And the thing is this, first of all, end-to-end tests, they take a lot of time to run. Even if you're good with them, after a while they take time to run. I've worked on a system where we had like 1,500 end-to-end tests. They did work, it worked, but it still took like 20 minutes to run them all in parallel. And that's still a very good time, like 1,500 end-to-end tests, 20 minutes. But then we had like a farm of computers, like 8 computers working in parallel, stuff like that, and we put a lot of effort into doing this. So we wanted to keep the execution time down. Also, there is something that can happen when you have end-to-end tests. Once you get them all working, it's very, very tempting to do some kind of like inverse test-driven development. It's like you take your end-to-end test, which works, and then you sort of say, okay, I have a test to, let's say the simplest case for the address book, I have a test to add a Darth Vader to my address book. Now, I want to verify that the last name needs to be set, right? So the application has to fail, the Darth Vader application has to fail if the last name isn't set. So what you do is you copy the end-to-end and Darth Vader test, and you just adjust it to include that non-happy path case. And this is how you get 1,500 end-to-end tests. And we wanted to avoid that. We didn't want to do that. That's why we decided for just happy path. Eventually, we wanted to arrive at this. This is an actual test. This is what we want to achieve for this system. Some people call this a smoke test. This is normally the first end-to-end test you will run. And this is actually the entire test.
But where's this set?
Well,
Where's this set? What are you checking? So you're just logging in and you're not checking if you're logging actually after that?
Okay, so the assert in this test is actually, if we're skipping ahead again, is actually in the infrastructure of the test itself. If the login procedure fails, there will be an exception. So it's an implicit assert.
Exception or
Depends on your infrastructure.
But I didn't see it from
Break discussion. Sorry. So again, we can get into the specifics of how to assert this, but this is basically what we wanted to achieve. Now it's just the way I build end-to-end tests. But please grab in the break. I love to talk about this. I will
the
convince.
whole presentation about that.
Ah, right. Okay. Cool. So we laid out a path for what would we do to get to the login test running with or without the assert. So that's here. Go. So we decided, just for the sake of this presentation, that I'm not going to talk too much. I'm not going to talk about the dependency spaghetti and the unit tests and stuff anymore, because that's just code. We decided to do these things. What I will do is I will sort of give you the path here. I will tell you what we did here for this particular system. And as you see, we started with a database. There are many, many reasons to start with a database. First of all, I just hate these ominous databases. But, oh, sorry, a bit ahead of myself. We started with a database. And the reason for doing this is that, in fact, it's totally unacceptable to really be ruled by an artifact from the past. A database like ours is installed 10 years prior to whatever you're doing. Ours was installed in 2000. It was basically installed by people in white lab coats from Oracle, and you go, whoa, you don't touch this database. This means that if you have system developers' point of view on this, you view your database as a storage, right? It's just something, you have a system, it's your system storage. But in this case, the database is an artifact. It's something that's supposed to outlive the system. There are actually people who attach value to it, and in some cases, that might be right. That database may contain something that will outlive the system. In this case, it actually didn't. But anyway, it's been there for 10 years. This means that a database like this amasses unused data, unused objects, unused procedures, unused views, pretty much everything. It just accumulates stuff, and it's really hard to see what's working and what's not working. Also, it's really hard, in some environments and organizations, it can be really hard to start talking to the people who are actually managing this database, because they are protecting it. In our particular case, we didn't have people protecting the database, but we had another scenario. I told you that deployment took 8 hours once, right? So how do we deploy a system for 8 hours? Even though you have this hieroglyph instruction, you can still follow them for like 10 minutes and you're done. I will tell you how. If you have 2 databases, one production and one the other database, you need a Superman. The Superman guy will sit, and during the entire iteration, development iteration, which was, by the way, far too long for this system, he has to sort of keep track of everything that's happening that touches the database. Now, on the time of deployment, this super guy has to go through, compare this everything else database by hand and see what objects have been added, what objects have been removed, what data has been changed, and just, you know, spot the differences. And this could take an entire night. The problem with this is that a guy like this still gets lots of credit. That's okay. I'm just talking. I'm just talking. That's okay. There is a slide. It just has nothing to do with what I'm saying now. I'm just talking about the Superman, and I want all the attention, that's why. So the super guy gets all the credit. He works through the night, and everybody appreciates a worker who works through the night. Right? Probably yes. Many organizations do anyway. So to get this under, another problem, by the way, with this is, again, a new developer would have to work on this other database, which was the shared database. So it was really, people were stepping on each other's toes, people were deleting data used by other people, and these end-to-end tests, they didn't work to begin with, but they were working far worse using a shared database. So these are sort of the reasons why we said we're going to do the database first. And to do the database, you have to do two things. Basically, you need to be able to figure out how to create the database. You need to be able to create it, and you need to be able to update it, to synchronize it. Now, creation of databases can be very, very hard. In theory, is about taking your production database, right-clicking on it in your favorite tool, pressing export, and then right-clicking in your favorite tool again, pressing import. That's like the theory of creating a database. Unfortunately, this is when you bring along all this garbage, these unused objects, unused relations, unused tables. So, now is a picture. What I propose, this is this method of working. So I'm not going to give you the most efficient, beautiful, elegant way of recreating databases. But you have to do this once. It takes 1, 2, 3 days. Our schema was like 100 tables. It took 3 days. You have to do this once, and you're going to have a beautiful database. So what do you have to do? First of all, you just start your application with an empty schema. You work the system, like try just to fire it up. What will happen is that this system will crash. For some reason it will crash. And now could be the time to tell you about one more thing we have to do when we work with databases. When we recreate a database and we want to start using it in an automated fashion, we actually, lo and behold, we have to know what kind of data is in there. It may sound obvious, but there are 3 types of data in a database. It's like entity data, let's call it like application created data. It's like, let's say it's a customer, an address, an invoice, network thingy. It's reference data, which is used by other data to sort of perform typing. Typical reference data is if you work with addresses, you always have a zip code table, you always have a city table, different types. You have currency tables. That's reference data, and you have a second type of reference data, which is application configuration data. It's a reference data for the system. So when you have these 200 tables and you don't know where to start, you have to start by typing your data. You have to know what kind of data they hold, because depending on that type, you will work them differently. You will, for automated testing, you don't really want the database to contain any data which is entity data. You want your tests to insert it. Either you want your tests to insert it, or you want to pre-populate that data. But what you need to do is you need to have your reference data and your application startup data. So you see when the system crashes, and then you add it. A typical system will want to read something from the database, like a path, or some kind of configuration information, and you will get a stack trace. So you add the table. While you do this, you classify it. Is it system reference data? Is it reference data? Is it product? Is it entity data? Probably it's not going to be any entities. If you need to, if you are doing this kind of thing, I know it's something, it says document. I should have put it higher. So if you are doing this kind of weird things like documenting your data model, this is a good opportunity to do it, actually. Because you're looking, you know everything about that object, you know in what context it appears, and stuff like that. Then you add, if it's a table, you add whatever is needed to get your system started. Then, you have your automated database script, and you just drop everything in that script. Drop the entire schema. And then you add your new object to it, and then you re-import. So you have a schema, you have a script, it drops everything, it adds this one single table. You make sure to automate this from the start, and then you just keep repeating. That's why it's sort of like this, because this takes time. But you do this once, and you really get an understanding for the storage of your system. So it is time consuming, but it really pays off, I promise you. The person who does this knows everything about your legacy data model, everything. This is like my favorite scene from Jurassic Park. So, provided that it says, I know this, it's a Unix system. Now, this is what we did for our database. Actually, I'm going to flip them off. You're just going to look at them. When we did this horse and plow thing, the result of this was that every developer got their schema, and we could finally create a system test environment which looked like everything else. So we had sort of a synchronized snapshot of our database. Now there was another thing we needed to do, and we needed to have the ability to synchronize all the databases. If we added one object to one database, we needed to be able to do that for several databases. There are many tools and methods for synchronizing databases out there. And we looked at three options. Basically, synchronizing databases is, in theory, again, very simple. It's about, you have a SQL script, right? The SQL script says, for example, alter table customer, add column middle name, right? And you want to make sure that all your 20 databases, or 10 or 5 or 2 databases get this change. So we just want to make sure that you replace the Superman guy who did this manually by something automated. So basically, you need something that runs this script and just writes in a table, I ran the script, like a changelog, right? So there are many tools out there, and our project evaluated 3 options. You could do this manually. We've done this manually in other projects. And doing this manually gives you control of whatever, of this procedure. So if there is something else you need to do, doing it manually is a good idea. It works, it's like 2 days of development, it will work. Then we looked at a tool called dbdeploy. The reason for looking at dbdeploy was mostly because we read about it in the continuous delivery book. It's like one word, dbdeploy. Actually, this tool is outdated, it's obsolete, it's very, very simple, but it is very, very simple. It gets the job done. Getting started with dbdeploy takes like 1 hour. So if you just need database versioning, then dbdeploy is the way to go. Still, it's old, and it's very well integrated with Ant, by the way. Our project was so legacy, so we were still building it using Ant. There's nothing wrong with that, by the way. So, good Ant integration. We also gave Liquibase, which is sort of the most heard of tool in this area. We gave it a quick look, but to us it appeared a bit too complex. It would take too much time to get started. And on an emotional level, configuring SQL in XML files didn't feel very right to us. So that's why we went with DB deploy. Check it out, it's really simple. It's the simplest thing you can do. Now I told you, we still have the challenges of automated deployment and this big black hole, right? And we approach them similarly. I mean, automated deployment is really only Unix. That's why I have this slide. It's just commands. It's boring, you have to type it, you have to test it, but it's just commands. But it requires something else. It required our automated database versioning to work. And it required our application server we needed to know its configuration. So, again, to figure out, if you remember my slide of this big black hole, to figure out that thing's configuration was again a matter of doing the plowing. There is no simple way out of this. We have had to start this thing, see where it crashed, add whatever was missing, restart. That's what we had to do. So in the end, after having done this, we came up with this procedure. It's as simple as it gets. Our deployment to both production and system test environments and the local environments sort of look like this. And again, it's very, very simple, but what we needed was database versioning and knowing the application server configuration. Before coming here, I just jotted down how many times we did deployment to our system test environment. 181 times during the course of half a year. If you do the math quickly, it's sort of like once a day. Now, not all of them were good deployments, they failed, they need tweaking, but basically we were able to deploy once a day. What this means, first of all, it means that basically, given that our deployment to system test took 30 minutes, not only did we get like 2 weeks, because 160 times 30 minutes will produce 2 weeks of work. We freed 2 weeks of work. But what's more important is the testability aspect to this. If we could deploy to a system test environment painlessly, that meant that we actually did this. And that's sort of a very, very important lesson here, that in order to achieve some kind of testability, you have to make things simple. You have to enable testing and testability. Otherwise, there's no way in hell anybody will test anything. So you have to open up, and this is one of the big door openers. Being able to deploy seamlessly and fast. That meant that these 2 weeks that we would spend deploying, copying files manually, could be used for exploratory testing, or just used for development. But finally, if somebody asked us, if our product owner asked us for a feature, what does it look like? We could just say, oh look, we're going to deploy it to a system test environment, you can have a look. So that's like a big takeaway. Get to this point, get to this stage where you can do this. And after a while you start noticing it. It becomes second nature to you. Now, what we did with the web tests is sort of the opposite of what we saw in the last presentation, but I'm just going to talk a little about how we cleaned them up. I'm not going to give you all the details of this, but our web tests failed because they were record playback tests. And that sort of never works. And again, for web tests, you have to apply the same principles as for any other software development. We have to have a good, neat structure. We have to put things in the right boxes. So we adapted sort of this way of thinking about the tests. All WebDriver stuff was put in one layer. There's nothing strange about that. Then we had page objects. Again, page objects it's not a new thing. Pretty much, I hope at least. By the way, I have time for a quick poll. Who does WebDriver? Keep your hands up, please. And lower them if you're not doing page objects. Yeah, exactly. So everybody's pretty much doing page objects. What's not apparent is that some people are still not doing this. It's sort of a layer above page objects, which directs and controls the actual test. And it's actually this layer that makes any test sort of resilient to changes below, because this test will be very very readable to a tester, to somebody who's not very familiar with the intimate details of an application. And this is those who like this, like domain modeling and stuff like that. This is really when you can shine. And these are actual concepts from the application. So it really pays off to invest in this layer, because this will give you all the language, the concepts in this application. And it's at this level that you want to write the tests. Now, there have been talks like 3-4 years ago. There were many talks on conferences where people talked about DSLs. Everything here had to be a DSL, a domain-specific language. And in part, that's true. This is where you have the language of your application. So this is how we structured our tests, and this is actually how you make these tests scale. So whenever somebody comes to you and say web tests are fragile, yes, of course they are fragile, they are more fragile than a unit test. But if you adopt this architecture for tests, or this type of layering, they will not be very fragile. And whatever dirt, whatever things will start changing, they will affect the lowest level. So like dirt, we had a lot of Ajax. We have the entire application is like one big Ajax call, and it just ended up here. Everything, we still had to deal with that, of course. So we had to do Ajax properly, but the upper level tests, acceptance tests, were completely isolated from it. So this is really how you should structure web applications, and it always worked. I haven't seen a case where a stack like this doesn't work. Now, there are some people who say, okay, in order to have something like this, we have to replace this with some kind of BDD or ATD framework. There are many people who say that you cannot run web tests unless you invoke them through Cucumber, or Fitness, or Concordium, or whatever. Now, if you're very, very fortunate to have people reading your specs, then go ahead. But really, don't invite that complexity. Don't invite another artifact to maintain just because you want a stat like this. So this is another takeaway. Keep it as simple as possible for these tests. So, pretty much, we did do the database through plowing, right? And we did some Unix magic here and more plowing here. And at this point, we could deploy stuff automatically. And finally, our test ran. Now, again, you could do this differently. This is how we did this. This is the sequence of steps that we employed. And we will have time for questions, so I'm very, very open to suggestions about different approaches. I'll just share some takeaways as well on a global scale, because this is something we've been doing for more than a year. So what is it I want you to sort of learn from my project? What is it I want to share? Again, if you remember this question mark, like overwhelming, update your CV, don't update your CV. Just, well, you could do that, it's kind of fun, but there is a way of attacking this. Don't be overwhelmed. Don't accept all these databases with people with white lab codes, application servers, copied around, magic zip files, rituals. Just deal with them. It's boring, you have to do the plowing, but you only have to do this once. And if you are in an organization where you sort of feel compelled to tell a manager about this, just don't. Just do it. And sort of striving for this automated, simple login test without the assertion proved to be a good guide for what to do next. Because it's all about handling complexity. What order do you do things in? So this proved to be a good guide, just saying, okay, in order to get to this automated test, we need to do this, but to do this, we need to do that before. So it sort of guided our approach. And what's both good and scary is that after a while, you get very used to this infrastructure. Everything is sort of automated, everything sort of just works. And that's very good. But there is a price to pay for this as well, and that is the price of working with an infrastructure, You have to sort of budget time, you have to remember that it's there. It supports your testing, it supports your process, but it requires some time, some cuddling. So please remember that. Now for some not very big insights, but just small insights. Again, not getting fancy with tooling. I mean, this you have seen like in every paper, every conference, like keep it as simple as possible and no simpler. That applied here too. I mean, we ran apt, we ran db deploy, we ran shell scripting, and it worked. We could achieve a full deployment. What eventually brought down our Selenium and end-to-end tests was the fact that in order to do web testing, you have to know what kind of data you're working with. You can't really decouple, like clicking in the UI you can't decouple it from what's in your database. If it is to be a true end-to-end test, you have to click in the UI and it has to leave marks in your data layer. Now, verifying the data layer is cheating, so you sort of have to verify through the UI, but the database has to be there. Especially in this case, where we had like thousands of PL SQL, thousands of lines of PL SQL code. So, in order to do this, you have to remember, yes, there is a WebDriver thing here, but there is a database here, and we need to be able to populate this. We need to be able to recreate it at will. In our case, we scrapped the database, the contents of the database, for every single end-to-end test. Just throw everything away, except for the reference data. And this is why you have to type your data, so you know what to throw away for an individual test and what not to throw away. Recording didn't work this time either. Again, please, if anybody's got record playback testing working, please grab me in the break, explain to me how. I'm really curious. And believe it or not, we did not need Cucumber to run our web end-to-end tests. We got away with JUnit. There is one final punchline to this. After having done all this, we felt sort of good about ourselves. We had automated tests, we Everybody had their own schema, deployment was easy, deployment was automated, everything just worked. Then, like, immediately, this came up. Now, that is just a random exception. I sort of rewrote it just not to tell you which organization this is from. This is just a random exception. And the lesson is here that this is really a manifestation of this obvious statement. People say, you can't test quality in. We had a very good infrastructure for testing. Our end-to-end tests ran, they scaled, we had control of database, we had control of deployment. We could do everything, but we still had these guys to deal with. And this is sort of part 2 of what's coming. And this is sort of my final word. You can't test quality in, no matter how good your test infrastructure is. And I think I have a few minutes for questions. Everybody's hungry. Thank you.